Okay, so you have seen like you've seen this shift in like last 10 years or say maximum 15 years, that there is a there is a hot topic about data science, right? That uh, people are talking about data science, and data scientist position became very hot nowadays, right? Everyone wants to know about data science and they want to become data scientists. Of course, money is an important part, but the thing is that why is it happening? Why is the case that companies are hiring a lot of data scientists, right? So there are still, you see many surveys, many magazines talking about that there are still positions left for data scientists, and companies are like very listing their data scientist role about that they are not able to hire right candidate for their particular position, right? And the reason behind this is that the growth of data in last like 25 years has been huge, like massive growth we have seen, right? So any portal you take, for example, if you take the entertainment domain, right? For example, we have OTTs like Netflix and other things, right? The data there is like huge, and whenever there is a data, you can do a lot of things with the data, right? You can learn a lot of things through the data, and you can predict a lot of things through the data, right? That has become prominent nowadays. Okay, and for that the main reason is that we have the right computation power, right? Now we know how we can use this computation power to do something with the data. Unfortunately, although the data which is increasing exponentially, we don't have right skill set. I mean, the increase in the skill set or the people who know what to do with the data is not that much. Okay, so there is a huge gap between the growth in the data and growth with the people in terms of like who would like to become data scientists. Although there are many people who claim to know data science, or they say that they know what to do with the data, but their skill set doesn't actually work with the practical uh, practical examples. When there are practical use cases, many people fail to understand and do something with it. That's where most of the companies are struggling with hiring the data scientist role. And even I have gone through many interviews. I have taken many interviews, and it becomes very easy to find someone who has gone through a lot of courses but still doesn't know what data science is. I mean, the person doesn't have the intuition to do something with the data, right? So again, this being a very introductory session, I will give you some kind of intuition that whenever you have a use case, how to come up with a very basic first principle solution, and then think about what you can do with it. Okay. So first, what exactly is data science? And you may have like listened or read like hundreds of definition about it. Data science is this, data science is that, data science has to do with the computation, data science has to do with the data. You predict thing, you classify thing, you do something, right? I mean, all those definitions are correct also, and not so correct also. Okay. But one thing I can assure you is data science is just a word which came new. The concept was always there, always by mean that till the man, I mean, since the mankind have evolved to Homo sapiens, from that time the data science has been there, right? The only thing is that now we call it a new term as data science, because now we compute everything through powerful machines, and our data is mostly virtual, right? That's the only difference. But the science behind is has always been there, and we have been using it empirically, not theoretically, but we have been using it, and we'll see some examples. Okay, so it's like a very famous scientist once from Stanford University said that data science is a new term, but in the same way that you the Columbus, you remember Columbus discovered America. So he said that I discovered a new island, but he went to a new island, but the island was always there, right? It's not the case that he went there and he created a new island. No, he was able to find a new one, but people were there. Native Indians were there in that island. So island was already there were biodiversity in that island. The island always existed. The only thing is that Europeans came to know about the existence of that island at that time. So data science is same way. we now say it that, okay, we understand things differently through data science, but data science has already been there. Okay, so let's talk about the timeline. Okay, so what has been happening is that like 1,000 years before, people were using the science behind data, but through empirical solutions, right? So whatever they see, whatever they analyze, whatever they see in front of them, through that they analyze and find whether this means something or not, or they predict or do something with this. That is known as empirical analysis. That whatever you see, based on it, you do something. Okay. Then few hundred years back, people started, especially mathematicians, started doing something with the data. They started generalizing it. They started coming up with theories and conjectures that, okay, if this thing is being satisfied, then something like this can always happen or may not happen. It becomes this came to the existence of theoretical analysis in whatever we see in the data. Now, the last 50 years, what happened that computer science came into the play. We had computers, okay, which can do all the computations for us. We don't have to do everything on ourselves or wait for a conjecture to come, right? We can feed the data to the computers, and the computer will do the work and tell us, okay, this particular thing is right or wrong, or can we do this, or if we can do this, what is the result? But in last 20 years, what happened that the computation power became very huge. And the reason is that we started leveraging the idea of GPUs, right? We started leveraging the idea of GPUs, which people were using in gaming. And we use GPUs and computation power with a lot of RAMs to process a huge set of data and started doing something with that, like coming up with new results, predicting something from the history of data set, or classifying things into various categories, right? That became prominent when we had the computation power, the right computation power. Okay, but this is very easy to say, like these were the case happening in last 20,000 years or few hundred years or last 50 years, last 20 years. This was a shift because of the what kind of computation power we had. But I mean, wait, what exactly is happening? Is there any example for that? Right? How exactly was this happening? So I'll tell you a story about this. Okay. So a long time ago, okay, and you can find this reference in like there was a very famous philosopher known as Thucydides, okay, and he wrote a book. In his book, he talked about the description of war, how Romans used to fight. Okay, so just see this video. Okay, this is a famous scene of a very famous movie known as Lord of the Rings, and you can see that let me play this again. There are a set of orcs, some other ethnic, and they are trying to climb a wall through ladders, right? Okay, so the idea is that these people are trying to breach the wall, and the way they are trying to breach the wall is through the ladders. So they have ladders, they go to the wall, they bring the ladder, and they climb the wall, and this is the way they can breach it, because the wall is very thick. Okay, and if you try to penetrate the wall through like try to break the wall or penetrate it with some other machinery, it's not very easy. If you try to do it, it will take a lot of time, and within that time the other party can kill you. Okay, so the best way is to climb it somehow. But here is my question. Okay, so my question is that for you being, let's say, a general of some other kingdom, and you want to attack a wall, attack a other kingdom, and you know that the castle is well guarded and it has a very thick and high wall. How will you even build a ladder? By that I mean is that how will you know what should be the height of that ladder so that you can climb the wall and do something, right? And it's not very easy, because at that time these things, that what is the height of the wall, what exactly is the height of the wall, were very secret, right? It wasn't very easy to know that, because the height was not always consistent also at that time. If you see the castles, okay, they made in such a way, and it was to be very secret, that people should not be able to climb it very easily. Okay. So for other kingdoms or for other parties to know this fact that what is the height so that we can climb it or we can do something, we can use ropes and whatever, was a very difficult task at that time. Okay. So there comes the idea of data science again. Okay. And you might be thinking that I don't understand how the data science is coming into play, but I'll give you the example. I mean, I'll show you how exactly people were using it. So let me simplify this problem again. Okay. And you try to understand the problem definition and try to see how you people were using the data science, a very basic idea of data science. Okay. But it used to solve a very huge problem, winning a war, right? So see the problem. So you being a general of some other kingdom, you want to attack this particular castle, okay? And this castle is well guarded by a very thick and very long wall, okay? You don't know the height of this wall. That's the problem. And the thing that you have to do is somehow you have to climb this wall, okay? But you not able to assess the height of this wall, you don't know how to climb it, or you don't know what should be the height of the ladder your builder should be building so that your army can go through it. So what people used to do, okay, and Romans especially, they used to send spies, okay, they used to send spies close to the wall, but not very close enough so that they are being spotted by the guards of the wall, but close enough so that they can count the number of bricks vertically. Okay. So again, they were used to send uh, the spies so that they can count the number of bricks vertically. Okay, like this. And they will send enough number of spies. Okay, they will send enough number of spies, a lot of spies they used to send, and the only thing they had to do is do this process, that they had to count the number of bricks horizontally. Okay, for example, one spy will count 1, 2, 3, 4, 5, and so on. Okay, something like this. So that's the process that every spy had to do, and they will send like hundreds of spies. Okay, so each spy will come up with a number, right? Each spy will come up with some number. So this spy thought there are like 1001 number of bricks. This spy said that there are 124. This spy will say like there are 968, and so on. Every spy will count something, and there will be some mismatch between them, right? Right. But the general wouldn't care. What the general would do, the general would send a lot of spies, and then the general will take all the values from these spies. And in the end, what he used to do is, in the end, he took every number. Okay, let's say this is number 1, and this spy gave number 2, and this spy gave number 3, and so on up to n numbers. And the general would just take the average of it. Okay, this is the average, right? This is how you compute the average of n numbers, right? So general would do this trick. This is the trick that he used to do. Take every number, take whatever they have come, whatever the count value they came up with, and take the average of this count value, average value. Okay, right? And surprisingly, the thing that was happening, that whatever the average value the general used to come up with, what exactly the height of the wall. Okay, I mean there will be some error, but the error was very, very low. Okay, so the error was the average, and the difference between average and actual was very less. Okay, very less. Okay, it was not so prominent that if you create a wall using this number, ladder using this number, the army were able to breach the wall. I mean, they were able to climb the wall and go through the castle and successfully do the attack, right? And you can see this in the Thucydides war of description on war. Okay, so this was very prominent at that time, and Romans used to do it, and people were not able to understand that how they were able to climb, because before that, for example, Ottoman Empire and other empires, they used to breach the wall. They used cannons and other things to breach the wall and then go through it. But Romans didn't do. Rather than, Romans always came up with this idea of building ladders, okay, and they will attack and they will go through the ladder, okay, climb the wall and get inside. This was a much easier task, right? So the idea is that Romans were using something which is known as collective intelligence. Okay, collective intelligence. Okay, and they're using a simple data science theory which says that the mean of collective intelligence, okay, the mean of collective intelligence is most of the time correct. Mostly correct. Okay, so by collective intelligence, what I mean that people, each one has to do a very little task, right? Each spy had to do a very little task of counting the number of bricks vertically. Okay, and that's what each person used to do. And by collecting their intelligent in whatever they did intelligently, that the only intelligent thing they had to do is count the number of bricks. And based on their numbers, they found that okay, these were the bricks they used, and these many bricks they used. Okay, and based on the length of each brick, it was very easy to find what kind of bricks they were used by the texture and the color, right? So bricks at that time were not. It's not the case that you have to manufacture it by yourself. Mostly they were marbles, right? So the idea is that based on the length of each marble and the count they came up with, they will take the mean. They will take the mean, and this mean was, through this mean they were able to create a right ladder through which they can breach the wall. Okay, and they did this for like, I don't know, more than 300-400 years. Okay. Okay, so this is one example of data science where they used one idea of collective intelligence plus the main theory of data science, where the mean, a simple mean, through which they were able to create right ladders to breach the wall, right? Okay, so let me give you one more examples. One more example, okay? So not so long time ago. So this is the case. This example is around like 1900 century. So there was a fair. So this work is known as the Preamble of the Ox by Galton. And what's the idea behind? So there was a fair. Okay, there was a fair in France, and in that fair, there was a person named Galton, and what he did, he came up with a challenge. He came up with a challenge where he had an ox. Okay, and he asked all the participants. Let's say there are n number of participants, n participants. Okay, so he asked all the participants to guess the weight of this ox. So the only thing they had to do is guess the weight of this ox. Weight of this ox. Okay, that's all they had to do. And during the guessing time, they cannot touch the ox, or they cannot use any machine to know what is the exact weight. They can only look at the ox. You just have to look at the ox and guess its weight. That's all they had to do. Okay, so many participants came. Okay, P1, let's say participant 1 looked at it and guessed some number. Okay, then participant 2 came. Okay, looked at it and guessed the number, let's say A2, and so on. Many participants came and starts guessing it by just looking at it. Okay. Okay. Now again, what Galton did, he took all the numbers, all these guesses, what participant did by just looking at the ox, took these numbers and again took the mean of it. Okay, n participants, n guesses, and he took the mean of this. Okay, and again, same theory was being applied, and he showed that when you take the mean number was actually very close to the actual weight. Okay, and he did this. I mean, he conducted this challenge many times. It's not the case that one time is a lucky case, right? But he conducted this challenge many times, and every time it was happening that whatever mean he was able to find through n participants, that mean was very, very close, not very equal. I mean, not equal, but very close to the actual weight. Okay, and again, the only theory he applied was the mean theory. Okay, showing that when many people come together and collectively, I mean, when you collect their wisdom, okay, so when you collect their wisdom or their intelligent answers, so they use some intelligence, although they were guessing, they use some intelligence based on what they have seen through their past history, right? They guess something. Okay, and by collecting their intelligent answers, suppose you can get the right answer. So each person had to do very little, right? Each person had to do very little. Okay, each person had to just guess the weight. Okay, and here the winning criteria was the person who guesses, the person who guesses, whose guess is very close to the right answer. Guess is very, like, very close to the right answer, right? The difference is very less, right? Will win the prize. So everyone has an intention to win. So they were trying their hard. So they were intelligent. It's not the case that I will go and jeopardize the whole challenge by just guessing some random number. No. My idea was that look at the ox, use my some wisdom, some intuition, some past analysis, and then guess a number, guess the weight of the ox. So everyone were using some kind of intelligence, right? Although they were just guessing, but some intelligence. And he proved it. When such kind of things are happening and you take the mean of every result, take the mean of every intelligent result, then it always mostly works. Okay, and the idea is, see, we are just taking a very simple data science concept, which is mean. You all guys know, right? Mean is just taking the sum of all the numbers and dividing it by number of elements that you have taken, right? So a very simple concept, and he was able to solve a very huge problem, that not even knowing the weight of the x, you can find the weight of the ox, right? Okay, someone raised the hand. What's the question? Can you please ask on? If you can ask the question on chat, I would answer it. Okay. Great. Okay, and after this challenge actually became so famous that so many people came up with this challenge in the fair. Okay, and what they had to do is keep an ox, and every participant had to guess the weight of this ox, and they stopped using the actual weighing machine to find the correct weight of the ox. Rather than whatever was the average, they will declare this as the actual weight, because they had the confidence and they knew this is very close to the actual weight. So they will say that whatever average you are getting, and the person whose guess is very close to the actual weight will win, right? And again, you can search this is known as Galton's experiments. Galton's experiment, right? Okay, now one more examples, which is very new, again very difficult, very complex, but the similar kind of theory has been used, right? Okay, now see the problem. This is very quite recent. Okay, so in 2012, okay, DARPA is a very DARPA is a defense organization of United States. Okay. And they usually come up with such challenges to solve very complex problems, like related to what will happen if some emergency arises, some natural emergency, something like that. How will you relay the information to people efficiently? Something like that. DARPA mostly works on it. Okay. So what this challenge was, what they did, the challenge was something like this. There were five people, okay, and these five people were randomly distributed among two continents. One is in North America, and second is in Europe. Okay, five people randomly distributed in these two continents, North America and Europe. Okay, and the participants of this challenge, what they had to do, they had to find these five people. See the complexity of this task. Okay, so you have five people. Okay, and you being a participant, you have to find these five people. Okay? Now, all these five people were wearing a very unique kind of t-shirt. The front of the t-shirt had the challenge logo. Okay, and the back of this t-shirt has a unique ID. Okay, a unique ID related to that person. So the participants, what they had to do, they had to click the photo of these two, that is front and back, and upload it on the server. Okay, so those who uploads the maximum will win. Maximum upload will win. That was the winning criteria. Okay. Okay, so you got the problem statement. Is everyone clear on that? Any questions here? You can ask. Okay, so again, let me repeat myself. The idea is that the DARPA came up with the challenge where they distributed five unique people wearing a unique kind of t-shirt, where the front of the t-shirt had the logo of the challenge, and the back had a unique ID related to that particular person. Okay, and these five people were randomly distributed among two continents. Okay, one is in North America, and the second was in Europe. Okay. Okay, and the participants, they had to find these five people, or more specifically, they had to click the photo of their front and back and upload it in the server. If they have uploaded the right person, I mean, the DARPA knows who are these people and what are their IDs. If they upload the right people, they will win. A maximum who does in the minimum time win. Okay, many companies, many teams participated. For example, MIT participated, Georgia Tech participated, and so many companies also participated. The winning strategy was something like this. Okay, what the winning strategy was, I mean, the team who won the prize, what they did, they created a tree kind of structure. Okay, so the team, what they did, they hire a few people. Okay, and by hiring, what they did, they told them that if you tell us one person, if you upload one correct person for us, we'll give you $500. Okay, for each person you get a $500. Okay, and all these were asked to do the same. So these were asked to, if you can outsource your job to other people below you, and if they upload the correct, you can give them, let's say, $100. Okay, okay, and they will hire a specific amount so that they can always make a profit for them. Team also hire a specific amount of people so that they can get the, after giving everyone their share, they can get the 50% of the amount, or so 60% of the amount. 40% they distributed in the tree. Same they did for this on the second level. Same these people did for the third level. They asked that whatever you guys are doing, I mean, if you give me the right picture, right, we will give you, let's say, $10 for each picture, and so on, and so on, and so on. The last layer was they were giving $1 for each picture. Okay, so they created a tree kind of structure with some depth. So this created a huge network. Okay. Huge network. Okay. So the idea is that using this network, they were able to find all the participants. Okay, I mean, find all the people, 5 people, in like 13 hours. Okay, and this you can see again that what they did, they used the collective intelligence of each person. So each person were using their idea and finding the right profile, and they were propagating it to their root. Okay, same thing they were doing for other, right? And similar kind of thing, every node, it was happening for every node. Okay. And by creating this huge structure, huge network, they were able to find into continents. Okay, so see the complexity. It's not like you are finding someone in a city. You're finding 5 people, that too with just 5 people, in 2 continents. Okay, that's a huge task, and they were able to do it in 13 hours by designing this structure. Okay, so again, the idea behind this, by the example, just I want to show you that how people were using the collective intelligence and simple data science. So the data science part was here, that they knew how people will behave based on the network that we are giving them, right? So they calculated that what part of share they had to reimburse to the people, so that they are incentivized enough to find the right people. Okay, that's the statistics behind that. Right. Okay, so what's the current scenario? Okay, where do you see? So these were very specific example, starting from the prehistoric, and then very historic sessions, and then a recent scenario. What exactly is going on? We see implicit such behavior everywhere, but we don't realize it. And one of the few examples are these 2 portals, right? So these 2 portals are again a very good examples of collective intelligence, right? Where they use the capability of each people's knowledge and segregate them to create a new good data, right? So in Wikipedia, for example, anyone can edit, right? Same goes for Stack or Flow. There are some restrictions, but mostly anyone can answer a query or ask questions based on some reputation and so on, right? The whole idea is the mass contributes here in both these 2 portals. And if you see, these 2 portals are very famous. You can mostly get the answers in either one of these portals, let's say related to programming only. Okay, and the reason is, again, everyone is contributing a little, and their segregated data creates a new profile, which is efficient, good, and credible. Okay, so whatever articles you see on Wikipedia, most of the articles are very credible, right? Everything is cited, well cited, and well written also. It's so good that Wikipedia people were able to like eradicate the whole Britannica encyclopedia. So there was a time when Britannica encyclopedia were very famous. But after Wikipedia came, Britannica encyclopedia had to go on. Yeah, because the quality of articles on Wikipedia were so good that it outlasted the Britannica encyclopedia. Okay. right? And where exactly do you use this data? Again, implicitly, we don't see it, but mostly these kind of data are very huge in mostly NLP process or even computer vision process or deep learning or data science, to be on a very general basis. So for example, whenever you ask something through Alexa, Amazon Alexa, right? So where do you think they pull the data, right? If you ask, tell me about New Delhi or tell me about Hyderabad, okay? So they mostly read the data. They mostly read the data from Wikipedia, kind of, uh, not Wikipedia, kind of exactly from Wikipedia, and they read the intro there, okay, and it will throw you out the uh, the knowledge that they get from the Wikipedia. Okay, so it uses such kind of data. Okay, so again, the idea is the data is the gold mine here, and the data that has been accumulated on Wikipedia kind of portal has been through a very unique idea of simple mean. Okay, so aggregate there is not exactly the aggregate we see in our data science, but it's mean only. By mean, I mean that people's knowledge has been accumulated inside this by the right features, right, and the right aggregated uh, features. Okay, and such kind of, for example, Alexa or Siri also uses this knowledge to do something on top of it. Okay, so they use the natural language processing, speech to text, to get the data from there, understand the intent behind the data, what user is exactly asking, and based on it, they pull the data from Wikipedia or even Stack Overflow or any other sources has been accumulated through people's knowledge only, and then throw it out. That's how the whole scenario is. Okay, again, coming back to the data science part, right? So what exactly is data science, right? So if I tell you the exact, so there is, again, there is no exact definition of data science. The whole, but on a very upper level, on a very surface level, it is a combination of three major things. One is the mathematics and statistics part. Okay, second is the computer science part, and third is the domain knowledge. Okay, at the middle of it, at the intersection of all these three becomes comes the right intention of data science, right? So you need some part of all these three to become a data scientist. Okay, you need some part of mathematics, you need a good part of computer science, and you need a domain knowledge. The domain knowledge could vary from, I mean, it's a huge thing. Okay, but the domain knowledge could be from humanities to core theoretical computer science. Okay, it doesn't matter, but the idea is what you can do with this data so that you predict or classify things. Okay, but on a very upper level, on a very higher level, this is the actual definition of data science. That to take all these three things, that is computer science, mathematics, statistics, and your domain knowledge, and you integrate them to come up with the intuition of data science. Okay, okay, but mostly you see other things with the data science also. For example, one thing I already told about mathematics, but with the mathematics you will see the statistics part. For example, in the previous example that I showed, most of them we were using the mean. Mean is the like very basic foundation of statistics, right? And you may have heard of it, the big data analytics. Big data analytics and data science are very like closely coupled. So without this, you cannot do anything related to data. Big data analytics is mostly you should be able to handle a lot of data, massive data, and how efficiently you are able to process it, and what exactly you are able to do with that data. Then comes the machine learning. Machine learning is that you apply you tell the machine that, okay, these are the things you need to understand the behavior of the data. For example, I give you cat, okay, and I tell you that when you see such kind of fur, and when you see such kind of eyes, when you see such kind of nose, then it is mostly, when you see such kind of size of an animal, then it's mostly a cat. Then whenever a new kind of such animal comes, you see the fur, you see the eyes, you see the nose, you see the height of that particular animal, and based on it, whatever I have told you before, you tell me whether this is a cat or not. Okay, that's where the machine learning comes. Data mining is again extracting the data. This data mining and big data I mean, they are again very closely related. Data mining is extracting the data from various sources, right? And you have heard of artificial intelligence. Artificial intelligence is like the big thing. The whole idea is making the machine think. Okay, we want the machine to think like us mostly. Of course, it's not possible as of now, but that's the whole idea. We want the machine to think like human, and whatever we do to make the machine think like us, everything comes under the artificial intelligence. Okay, but where do you exactly see the big data, right? I've also already told this example before, but mostly whatever the things that you are using right now, like, so mostly everything has become virtual, right? Even the world is becoming virtual. So there is a concept of metaverse also, that the whole idea of real world, we are taking it to the virtual, so that as a virtual you will have some identity, and that person will exist in virtual world and would be able to do all kind of things. The person can travel virtually, the person can do the transaction virtually, the person can buy something virtually, right? That is metaverse. Okay, so all the applications such as Facebook, Amazon, Google, LinkedIn, whatever you see, and Netflix, right? Whatever you see, all these are based on, I mean, all these uses a lot of data. They have a lot of data, huge amount of data, right? For example, last time when Facebook showed their graph network, right? The graph had around 3 billion nodes, which means that 3 billion people were at that time using Facebook or registered to Facebook, and they had then a closed network of 3 billion people. But currently, if they do not, I mean, that getting the graph, Facebook graph, is not possible right now. They have stopped the API of graph, but mostly now it's more than 5 billion. Okay, so the amount of people who are using an amount of data, each of these portals is like huge, and you can do a lot of things. Even they are not able to do much thing from their data. They just have the data, right? But they're still struggling to do things from this data. And what are the things they can predict? How can they add value to their market, right? Now, getting to the part where we want to become a data scientist, right? So let's say I'm starting from the basic. Okay, what are the things that I need to understand? What are the skills I need to have to become a data scientist mostly? And I'm talking about the current scenario, right? What companies are mostly looking for, or if you want to become an entrepreneur also, what are the skills that you should have? The first thing which is very much appreciated and required is a T-shaped skill. So what do I mean by T-shaped skill? That whenever you start learning the data science, or you want to understand, or you have a use case and you want to do something with that, you never become you don't become a very specific data scientist. And by specificity, I mean that it's not the case that if you are working on a particular use case, you always work on things which are related to that use case. Okay, so for example, let's say I am a natural language processing scientist, and I work on, let's say, legal language currently, and I make myself very acclaimed to the legal languages only. I say that I will only work on legal languages and do everything related to that. Other than that, I don't care. So such kind of skills are mostly not appreciated. Rather than, you should have a T-shaped skill, and by T-shaped I mean is that you should have a broad knowledge also, right? You should in general understand what AI is. You should in general understand what data science is. Okay, you should have the intuition. You should have the intuition of data to do things from it. Okay, that is the broad category. Okay, so that whenever the shift happens, you should be able to cope up with the shift, understand the data. So let's say if you want to shift something, and rather than NLP, you want to work on computer vision, you should have the right intuition. So if your fundamentals are clear, you have the broad category of right intuition, you will be able to easily cope up with the computer vision. right? Even if you are some other domain. So that is very appreciated, that the person should be able to cope up with new things, new features, okay, new capabilities, plus new APIs and new programming languages, because programming languages also changes with time. Today, Python is very famous, but you don't know what will happen tomorrow. But yes, with the broad category, you should always have the depth. Okay, so in one domain knowledge, you should be the master. Okay, this will always happen. This changes also. So sometimes you are working on some other particular use case and you become very good at that particular domain, and then you might shift your domain, but you always keep a depth in that domain. So in general, this is known as T-shaped skill, where we assume that the data scientists have a broad category of ideas. The, the data scientist knows what exactly is the era behind, what is the current scenario going on, what are the cutting edge researches people are doing in various domains, plus the person knows the deep understanding of the domain. Okay, that's the first thing that is in general required from any data scientist. Okay, now where if you become a data scientist, let's say, or in on a very, let's say, uh, you you being a fresher, or even if you have some experience, where exactly do you fit in companies? And again, I'm talking about the current scenario, right? So currently the idea behind the companies were structured like this. Okay, there are domain experts, and of course these things vary based on the size of the company and structure of the company, but this is the in general scenario. So there are domain experts depending on the size of the company. If it is a startup, these could be CEO or CTO, right? Or if it is a little bit big company, or in general a medium sized company, this could be a research scientist, right? Okay, and these people have the idea about the product, what exactly is what kind of product they are building, and what kind of research analysis they are doing in their product, what AI features they are using in their product, right? So they have the business and domain knowledge of their product. Okay, then comes the data scientist. Okay, data scientist's job is to communicate with the domain expert and with the team, with the development team, plus implementing the overall data science feature. Okay, so the data scientist is responsible for implementing the data science features. Okay, plus the data scientist should be able to communicate with the stakeholders or the domain experts about the product, what exactly they are building and how they are implementing it. Okay, plus the data scientist should be able to communicate with the development team to tell them that how whatever features the person has built should be implemented on the back end. So whatever you will be building, so in a way should be implemented in some kind of API or web server or somewhere, right? So the app developer or operational developer should be able to integrate it in the back end, okay, which goes to the some kind of front end, whether it is an API or whatever it is. Okay, that is the job of app developer and DevOps, right? So data scientists should be able to communicate with them. So it becomes a very major and responsible job, okay, to take care of this part also, to make the feature, so implement the feature in such a way that app developer can easily integrate it in their systems, plus knowing the knowledge of the overall product and the business analysis, so that person can communicate with the domain experts or stakeholders that what exactly has been built to make their product more valuable. Okay, that's the job of data scientist nowadays, to be honest, right? Okay, great. So I'll talk about what are the things that are required from a data scientist, and what are the skills that you need to become a data scientist in the current scenario. So one thing which is very common and everyone should understand that a data scientist should know how to code. Right? So coding becomes the most important thing. So whatever domain you are coming from, whatever specialties you want to have, you should be able to code, right? And there are two ways, to be honest. Okay, there are programming languages which work on a very higher level, and there are programming languages which work on very lower levels. Okay, so by lower level, what I mean that these programming languages, for example, C++, Java, okay, these are very relatable to the machines. So you have to do a little bit of more effort to understand and interpret your logic into these programs, translate your logic into these programming languages, and then let the machine execute or run all the instructions. Okay, so these programming languages are more closer to the machine, so that machine can easily understand it. Wherever the high level programming languages are those programming languages which are more closer to the user. So user can easily work on those programming languages, do something with it, but machine takes a little bit of more, it becomes a little bit complex for machine to do something through it, or it takes more time. Okay. So some programming languages such as Python, R, you must have heard of. These are high level programming languages, which are more closer to the users. Okay. And in most of the data science courses or jobs, you will see that Python and R are two very famous programming languages that most of the data scientists use. But there are, I mean, people use Java, C++ also. But in most of the cases, Python and R are the programming languages we data scientists use. Okay, and there is a very good reason for that. Why people are using Python or R for data science. Okay? And the reason the reason is that the first reason is the Python is very simple. Okay, it's very close to the English language, so whatever you are doing becomes very intuitive. Okay, so for example, a simple program to write a hello world in programming language such as Java or even C or C++, it will take some, you have to write a set of instruction to do it. Whereas in Python, you do it in a single line. And there are so many complex operations that you will be doing in single line, right, in Python. Whereas in other languages, you have to build everything from the scratch and then do it. So Python makes things very easier for the user or for the programmer. Okay, so you don't have to take care. So it offers a lot of abstraction also. So you don't have to take care what's going on behind, and you don't have to build everything from the scratch. Rather than there are libraries and modules which are already present, you can directly use them and do whatever you want to do with your data. Right. That's why it's very easier for data scientists, especially because the idea behind data scientists is not to get into the software engineering part, right? The idea is that you should be able to get the intuition of data, and you should be able to translate your idea into programming so that you can analyze the data and show what kind of things through this data you can do, what are the things you can predict, what are the things you can classify, and so on, right? The second thing is that Python offers a lot of powerful libraries and APIs. Okay, so if you go through this course, you will see you will be learning a lot of powerful APIs related to various machine learning or data science concepts or managing data concepts. Okay, and these libraries will help you do those stuff in a very simple way. For example, NumPy, Pandas, and for deep learning, machine learning, you'll be using TensorFlow, PyTorch, scikit-learn, and so other things, so many. So all these libraries will help you implement things not from the scratch, but to directly use the features and directly add your data and features of your data and use this library to predict or classify or get the results from your data, right? So you don't have to build all those functionality from the scratch. For example, I was talking about mean in our previous examples, right? So you don't have to build the function for mean from the scratch. Rather than you can directly use a mean function from NumPy library and you feed the data inside it, whatever data you have, and it will give you the mean directly. So it's a one-liner code, again, a one-liner instruction. So that you will see very, very complex operations also, which you can do through one line. And Python libraries makes it easier for you. That's what most of the data scientists role requires you a good understanding of Python or R, right? But in our courses, mostly you will be seeing Python only, right? Okay, so I'll talk about the current trend. What kind of skills currently people who are working in this profile, having the data scientist profile, what kind of skills they have right now? Okay, so there was a company, 360 Data Science, and they surveyed. They took the data of around 500 profiles, LinkedIn profiles. Okay, and in this, they only chose those profiles, people who have mentioned data scientists in their profile somewhere. Okay, so they took such 500 profiles and did the analysis on these 500 LinkedIn profiles. They found out TensorFlow is, so when you go to the, yeah, Ramesh, I'm answering your question. So when you go to the deep learning part, then it becomes kind of necessary to understanding. But it's not the case that TensorFlow is the necessity, right? There are other libraries also which you will learning, scikit-learn and other things, right? Which will help you to do the overall data science. But yeah, when you see the deep learning, either you will be using TensorFlow, Keras, or PyTorch kind of things. Okay, so what they found that, of course, this is the trend in 2017. This data is 2017. Currently it has changed a lot, but they found that 70% are mostly male. Okay. Second, most of the data scientists, they at least speak two different languages like English or some other foreign language, right? The other thing that they found that most of the data scientists, they have either 2 years of experience of on an average, or they have like around 4.5 years of experience, uh, uh, including the previous role which they have before the data science. Now the most important part is most of them, around more than 50% of them, they said that they are working on either R or Python. Okay, and then 70%, 75% of the data scientists has some kind of master's degree, and this master degree were also online certification also were included, right? So they had either, very few had very PhD degree, but many have that online certification or some kind of master degree or advanced degree or advanced certification, right? So this was very prominent in the data scientist role which they found. Okay, okay, again, going back to the programming libraries or features or the software they were comfortable with, mostly they found that people are using either R or Python. Most of this, for example, you can see 53% of them were using either Python or R. 40% of them knew the basic database, either SQL or no SQL database, like such as MongoDB, which you will be learning in this course. And then very few, like around 90%, were using MATLAB kind of feature or Java, okay, or C++, right? These kind of programming languages. But mostly you can see the Python is very prominent, Python or R, both. Again, what's the difference between R and Python is that through R also you can do all those things which you can do through Python, but R is a little bit inclined towards the statistics. Okay, so statisticians mostly use R because it's very good to do the statistical analysis through R. Whereas Python is more diverse. Okay, so with Python you can do all the machine learning part plus the statistics part. Okay, plus the more comfortable part that you get with the Python is the community of Python is extremely strong. And what do I mean by this? That if you have a question, you will definitely find an answer somewhere, mostly in Stack Overflow or somewhere, right? So it's because the community is very strong. People are extensively working on Python, and new libraries are coming. Every problem has a solution, or someone has seen that problem and tried to solve it, and something like that. So since the community is strong, and if by any chance if you come up with a problem where you don't find a solution, if you ask that question, there will be someone who will be helping, right? So Python has a very strong community, since it is open source, and plus the community likes Python, likes working with Python. Okay, this is this is for all of you guys who are working in some other field and want to shift to the data science. These in this analysis, they found that most of the data scientists, 2 jobs before, so currently they are a data scientist, what they were using 2 jobs before. So they found that around 25% of the people, 2 jobs before, they were not into data scientist position. They were doing something else, like completely something else. Around 9% were consultants, 12% were just interns, right? So if you see, like 16% or even 4% were in academia, like even just 16% or 14% were into the data scientist role or IT specialist role, right? But most of them were not into the data scientist role. What especially 25% were not even in IT, right? So this is very important. They were doing something else, but they shifted to the data science role and they were doing very good. And what they found, that 1 job before, I mean the previous job, mostly they found that on 60% of where they were, this is also a huge thing, that 60% of the people were not into the data science job. They shifted to the data science position. Okay, right. And only 7% were actually IT specialists, or only around 36% were data scientists. Okay, but most of them were not data scientists and they shifted to the data science role. Okay, which is kind of an opportunity for you guys if you are trying to shift. So it's happening, it's already happening, and it's not the case that you cannot shift. Of course, it's very possible, and people love people coming from different background, right? And again, the other thing that they found, that again, this is very interesting, that only 20% of them had the knowledge of computer science. Okay, 19% of them had the previous knowledge of statistics and mathematics, but most of them were from different backgrounds. Some were from engineering, some were from natural sciences, some data science they knew, some were from economics and social sciences, no idea about computer science or statistics or mathematics. I mean, the kind of mathematics we use in data science, right? But they still shifted to the data science. So the idea is that although they were from different background, they had the right domain knowledge, right? And using this domain knowledge, they were able to translate their problem into the data science problem and compute whatever they wanted to do. That is the main crux which is required, that even though your domain is very different, are you able to translate your problem into the data science use case? And then can you do something with the data that you have? Do you have the right intuition? Do you have the right intuition about your data set, right? Now, again, the last thing which they found is that people who mostly have a LinkedIn profile, right, 40% of them have some kind of online certification, right, in their profile. Okay, so people who are already working as a data scientist, they've seen that most of them, like 40% is again a huge number, most of them have some kind of online course certification, or online, they are pursuing some online course, or they have some online degree they're doing, either pursuing or having, right? It is becoming very prominent, because nowadays getting job is mostly through LinkedIn, right? Because the LinkedIn recommendation is very good right now. And so this is just a statistics that I'm telling you. This is again a data science. I'm telling you the data for what people are, what has been happening in the past, and what do we expect to happen in future. So if you, being a data scientist, would like to create a LinkedIn profile, it kind of becomes very necessary for you to attach some kind of extra online course degree, a very good online course degree, right? Where you are getting taught by some uh, uh, industry expert, or good academicians, right? But they also found that around three, on an average of 3 people have some kind of certificates that they have done. They have already finished some course. Okay, and these people, and these again, talking about the survey was taken for those people who are working in as a data scientist in Fortune 500 companies. So it's not like that anyone who has written data scientists were taken. No, people who are working in Fortune 500 companies were only taken, and these are the traits that they saw in these people, right? So online course, a very good online course, and they have done that online course with right projects and with right mentors, becomes very prominent. With it, it it marks a very good thing about their data scientist attitude, right? In India, the current scenario is that mostly data scientists work in IT related uh, technologies. I mean, IT related companies which are offering IT related things. But this shift is different in other companies. For example, in US, mostly data scientists are working in industrial, right? So by industrial, there is a manufacturing company, and they also require data scientists, okay, because they are transforming everything with artificial intelligence, right? So this shift is also coming in India, that people, for example, if you have seen uh, new startups related to cars and bikes are also coming. So for example, there is a new startup, Proveg, and their car is like totally AI automated, right? They are also building the self-driven car. So at that place, you will require someone who knows the automobile engineering, a good knowledge of automobile engineering, plus he or she is a data scientist, right? Such kind of profile, if you have already built such kind of profiles, let's say you are from mechanical background, and then you understand the data from in your background, and then you understand the data science. By data science, I mean that you know how to use the data, and you know how to process your data, and you know how to get the result out of it. If you have those kind of skills, they would love to hire you, right? So that's the idea, that's the shift that's happening currently in India also. Okay, let's quickly talk about some of the applications that we see nowadays, which are related to data science or artificial intelligence, right? One application I've already told about is the speech recognition, right? You use Alexa, Siri, or Cortana, or Google Home, right? Those things. They work on natural language processing, right? And the idea is whatever you say, they try to understand it, not just represent whatever you said into text, but to understand the intent. Okay, so I can say that call an ambulance, and or I'm feeling something. I don't know what to do. I need to go to the doctor. The app should still be able to understand that this person is feeling some kind of issues. I should call an ambulance. That app should be able to ask you, do you want me to call an ambulance? So to understand the intent, right? And these applications, for example, Siri and Alexa, they become so good right now that they understand the intent. So if you tell Siri that I feel that I am having a chest pain, I don't know what to do, I'm feeling so anxious, it will ask you that I think you are having something, should I call an ambulance, something like that, right? So it understands the intent. Okay, now in gaming industry also nowadays, you will be, so if you are into gaming, there are many games which talks about which are using very uh, intensely with the artificial intelligence. There was a game which I played, which is known as Detroit being becoming human, and in that game, the way you proceed to the story, the AI interface that they have creates a new pipeline or a new story based on it, how you have played till now. So based on your history, what kind of decisions you took, what kind of things you did, based on your intention in that game, a new storyline, a new branch of the story emerges, right? So this is becoming this is a very cool experience that you see in gaming industry, right? Now in fraud detection or risk detection, now it's purely into getting into the data science or AI, right? For example, if you see the captcha, right? You remember there was a time when captcha was like, there was very shady kind of fuzzy kind of words were given, and you had to write those words. It's still there in some places, right? You have to write that word for captcha to verify whether you are not a bot, right? Now if you see Google captcha recaptcha version 3, you can just Google it and see. So it doesn't even it doesn't even ask you for to check the box. So now most of the web pages or API, they use that checkbox, right? Where you have a checkbox, you click on it and they say whether you are a bot or not. But now the Google captcha version 3 doesn't even ask you. It doesn't ask anything. Based on how you are behaving, how you are using your cursors, how you are using your keyboards, right? Based on those behavior, they identify whether you are a bot or not. because the bots, the kind of bots hackers use, or the kinds of bots we use to uh, crawl the web pages, they're very specific in a way. Their directions are very specific. They go to a particular link, then go inside that particular link, then go inside a particular link and extract the data from there and do something there. So they're very deterministic, right? Wherever the human, the way they behave on a web page is not very deterministic, right? You look somewhere, then you use a cursor somewhere, then you click on somewhere, then you go back, do something else, you do some kind of those things. So it's kind of a little bit random. So they use such kind, so they learned this behavior by many sample data, and they understood that how humans behave and how a bot behave. So now the Google version 3 recaptcha doesn't even use that. You don't have to do anything, and it will understand that whether you are a human or not. So that's the thing where the data science and machine learning is being played again. Augmented reality is other thing. I talked about the metaverse, right? Where the whole virtual world has been created and you can do most of the things. One good example was that game which came like Pokemon Go, right? There was again a real world where you could see real Pokemons and you can catch them and do something with it, right? There is a there is a Firefox web service, something like that, where you can attend a virtual conference by you being a new identity inside that virtual world. You can do interact with people, you can talk to them, you can give their voice to it, right? And you can do all sorts of things, make some decisions also. All those are driven with the data and the science behind it, right? And of course, you know the self-driven cars. So self-driven cars is a very complex process because it has the date the I mean, the car has to see a lot of parameters, right? What kind of road it is, what are the things that are coming, uh, okay, what kind of obstacles I can see, what a person is doing in front of me, and I mean, so many things. And based on it, the car has to make a decision in milliseconds, right? So this is something again which is data driven. So based on the past experience, car has learned that what kind of things happens, and then what kind of decision I should take when something like this, because in road anything can happen, especially in India, right? So the overall thing is nowadays the data is the gold mine. Okay, 20 years before, or I would say 30 years before, algorithm was the gold mine. So the idea was you build an efficient algorithm in such a way that your whatever the use case you have is correct, it works efficiently, and it gives you result in less resources and less time, right? That was your constraint, and you had to build experience algorithm based on it, because we didn't have much data at that time. Although even if we had the data, we didn't have the computation power at that time. But now, since we have a lot of data, everything became virtual, everything became digital, and we have a lot of computational power also. We have like supercomputers, gigabytes of memory. Even nowadays, whatever mobile you are using, it has gigabytes of memory. Processor is very strong, right? You can do a lot of things which you were not able to do 20 years before. And because of that, now data became the gold mine, right? So getting pure data, or by pure I mean good data, which is labeled, which you know, which you understand, which you know the how data is behaving, you know how what is the intuition behind the data. Such kind of data, if you have, you can do a lot of things through it, right? So nowadays the shift is like data has become the gold mine, and you being a data scientist, if you understand the data and you know how to get such kind of data and do things with it, then you become a very good data scientist, and every company would like to hire you, right? That's the key idea that I wanted to give you through this lecture. So the whole thing that I wanted to go through this lecture was to give you a very preliminary intuition behind what data science is, how people have been using data science where the term was not even invented, right? The data science term was not even there, still people were using it, whether it is empirically or theoretically, but people were using the data science. So I gave a very simplistic example of it, that people were using meme to do very to solve very big use cases, right? And then we talked about how the data a good data which are collectively collected on portals like Stack Overflow and Wikipedia are being used by some powerful API such as Alexa or Siri or any other portals, right? And they are doing some analysis and throwing out the data back to you, right? So you feed the data and the data comes back to you. It's a cycle, right? And then we talked about that what are the things that, what is the current scenario, what kind of things which are expected from a data scientist, what kind of skills which are expected from the data scientist, what current data successful data scientists, what they know, right? What kind of programming languages they understand, what kind of programming languages they use, what kind of broad skills they have, what kind of domain knowledge they have. Plus we talked about that what kind of shift we are seeing right now, right? People from various domain are also becoming data scientists, and this is helping the other industries to flourish, right? For example, me being a data scientist in, let's say, NLP, and I have been working for NLP, let's say, for 5 years, 6 years. If I go to a manufacturing company who would like to someone who understand the manufacturing process and use the data science to do something about it, to streamline everything using the AI feature, they won't, of course they can hire me, but they will resist. Rather than, they would like to hire someone who already knows the manufacturing process, already have worked through it, right? Plus they know the data scientist. So this is a shift that everyone wants, because nowadays the AI is going towards all the domains. So every domain is trying to capture the AI capabilities and do something with it, automate everything. And for that, they need domain experts who are data scientists, right? So this is the shift that we are seeing right now. Okay. So